Welcome to the solution video for the Soda Machine Data Access Challenge. Let's go over to the source code and get started. So here I have work. So these are the methods we have to fill out, but we do need to do something a little bit lower level where we're actually storing this information. So storing our values and retrieving them. Now, what values are we going to store and retrieve? Well, if you go to models, there's only two models here. There's probably a little bit more than that we need to store, but there's two models at least. The coin model, which has a name and amount, and the soda model, which is the name and the slot occupied. This gives us our first two pieces of data, or two types of data we need to store. So we probably need to have a text file that stores coins and one that stores sodas, but we'll check on that and make sure. So we have the coin inventory. So we have to know what's in the machine. So that seems like it's a data storage. We're going to store information about coins. What coins are currently in the machine. And we can add coins to it. We can withdraw coins from it. We can check what's in inventory. I think that's probably one right there. Then we have the machine info, which we have cash on hand, empty cash, soda price. This seems like a text file entry that's just really simple. It's maybe not even a simulation of a database. It's just four entries. You've got your cash on hand, and you have your soda price. Those are two different lines. Then you have your total income, which is another line. And is there one more piece of information here somewhere? I thought there was, but maybe that was it. Maybe it's just those three pieces of information. Let's look real quick at our mock data access and go down to the machine info, which has three pieces of information. So machine info has soda price, cash on hand, and total income. So it's reassured me that we only have three pieces of information to go into that particular storage mechanism. So we have the machine info, and then we have our soda inventory. So we have a list of sodas and what slots they're in. All right, so you can check if a soda is in stock. We can get all the soda. We can get a particular soda out of the inventory, and we can get the different types, which is just get the whole list and then just return the different types. And then that's all the soda information. Then we have user credit, and this is short-term storage. I don't even think that this necessarily goes into any type of database situation. This could be just in memory, because the user credit, they're putting information into the, or money into the machine. It would seem like we wouldn't need to remember that between application shutdowns. So the only time that'd be a problem is if the machine shut down, was unplugged or something like that, when you're putting money into the machine. But it would seem like that would be a problem no matter what, if it was a physical machine or not. Remember, we have to give the ID, that GUID of the user, in order to get this information. How much credit they have, and to clear their credit and all that kind of stuff. So if the machine shuts down, which would be the user interface as well, then unless the user interface is storing that GUID between restarts, then we wouldn't know this information and it would get basically lost. So we don't have to store this information, but I think we're going to. And the reason why is because if we were to use this in a web environment that does not have session state, then this would get cleared out and start over every single time. So I think we do need to store this somewhere. So we'll store just a little bit of information about the user and their credit information. So that would be simulate a table in a database. So we'll have the user's GUID and then their amount. So you can get the total from that. You can add to it. You can deposit that, which I believe what that does is it puts it into the machine's value. We can check that with our documentation, which is our unit testing. And then we have clear. So we can do all those with just that one entry. So the database or the text file will have the GUID, and then it will have the value for each user. So for that user. So the GUID, and then let's say 25 cents. And then if you want to add something, you pass in that GUID, and you say add 25 cents. And so it's now 50 cents. So that's what we'll do. So each of these is a little bit different, but we're going to address them one at a time. So let's start with the coin inventory. We're going to create a private method. And it's going to be a list of coin model. And this is going to be coins underscore, or should you say retrieve coins? I think retrieve coins makes a little more sense because that way we're going to have retrieve machine info, retrieve user info, and retrieve soda info or sodas. That way they're all listed together in IntelliSense, and okay, this is what each of these methods does. You have to search for it. So with that, we don't need to have anything passed into this. We'll just have it return information. And so we'll say list of coin model output equals new list of coin model, and we'll return that once we have it, but we need to retrieve it somehow. Where are we going to store this information? And I think the answer to that is we need to store it somewhere we can change it. We don't want to just hard code a path here. So what we're going to do is we're going to create a constructor for this class. We're going to ask for an I configuration. Control dot to install the package Microsoft.extensions.configuration.abstractions. We'll call it config. We'll control dot to create and initialize the field. And it's acting a little slow today. Let's try it again. There we go. And now that we have this config, we can use that to retrieve some information. Now let's retrieve it up here so it's just kind of locked in. So we're going to say that we'll have a private string, and then we'll have our coin text file. How about that? And we'll start with saying that the coin text file equals config.get, and actually what I want here is get value, but it's not listed in this list here. And the reason why is we need to go to manage NuGet packages, and we need to go here and say Microsoft.extensions.configuration. I believe it's binder. So Microsoft.extensions.configuration.binder is what we're looking for. We install this. And what this does is it gives us some additional functionality with our iConfiguration, which allows us to do this get value. And this allows us to read right from the configuration easily without having to get section and kind of parse it, get value. And we're going to say this is a string value, and then you just give it the key. And so the key is going to be the name of our item. So we could say, how about text file storage, if I spell it right. And then in here we'll say coins. Okay, what it's going to do is going to have a section called text file storage. Inside there we'll have a property called coins, and that's the value we're going to pull in. So now this is right now in app or an app settings.json file, which we don't have yet because we don't have yet a user interface. So some of this is going to work that we have to do kind of without an easy way of testing it. Now we can put this in a unit testing, but there's not a ton we can do with that testing. So I'm not going to put it in a unit testing. I'm just going to create this data access, and then the next lesson we'll actually wire up to a user interface and verify it all works. It's not ideal, but at the same time, this is what you have to do if you're trying to break these things up into parts in order to do one part per week. So we're going to get the value for the coin storage, all right? And that's going to be that text file. Now I'm going to assign an initial value of empty string. Actually, no, I'm not. I'm not going to do that because I think it'd be just fine to access this. Once in a while, the system will give you a problem saying, hey, you haven't initialized this value. But I think if you put it in a constructor, it will verify that, yes, it's been initialized. So with that, we should probably create a couple more. So private string soda text file and private string machine info text file and private string user, what do we call it? User info? We called it user credit. User credit text file. Okay, with those four, we can essentially copy and paste this line. We'll do it 4 times, or we'll change each of the values here. And then we'll change where it pulls from. So instead of coins, this will be soda. This will be machine info. And this final one will be user credit. So now we can start using these strings as the location for the files that you want to access. So let's add our using statement up here for system.io. Using system.io, and that will allow us to do things like file. So we can say file.read all text, not read all text. I want to read all lines. That's what I prefer. That's going to put each line into a separate entry. So read all lines from the file path. Well, this is going to be coin text file. And what this will do is this will read all the lines into a string array. So we're going to say, let's say var. We don't have to say string array if you don't want to. Var, and then we'll say lines equals. Okay, so now we have all the lines of our text file that stores our coins in this lines variable. Now we can do a for each line in lines. And then we can do a split on this. Now we're going to have this file be a comma separated file. So we're going to say that the entries we're going to split apart. So line.split, and we're going to split it based upon the comma character. All right, and this is going to create another array. So a string.split creates another string array. And this will be for each individual entry. And we can call this data. So we have data now. That's going to be each individual cell. So if you think of a spreadsheet or a database where you have rows and columns and then each individual cell, Well, this line is one individual row, and then the data represents the different cells. So let's look at what a coin is going to hold. If we look, we have just two pieces of information. We have the name of the coin and then the amount. So now we have this data. What we can do is we can say output dot add, and then inside here we can say new coin model, and then have our name equals data at position 0. We're going to say name's going to be first, and then our amount is going to be the data at position 1. Well, not quite. And the reason why is because this is not of type decimal. So we have to do a decimal. Let's just do a space here. Decimal dot parse, and then parse this string. So this will be our amount that goes into the amount field. This will be our data that goes into our name field. And so we now have our name and our amount. Now, this does mean that our text file has to follow this format. It has to have name first, and then it has to have amount, and they have to be comma separated. And that's all that should be on the line. And some people get a little concerned about that because of the fact that you're hard coding here at position 0, you're hard coding at position 1, you're hard coding that it is a decimal. And yes, those are all true, which does mean we should wrap this whole thing in a try-catch. Because if it doesn't work, it's going to crash the application. So let's do a surround with. Let's scroll up here first a little bit. It goes off the page. So we have our snippet, I believe. Yep, snippet surround with. There we go. And we're going to say not my code snippets, but Visual C#, and then try. So that wraps it in a try catch. You could have just done a cut, select this whole thing, do Control X to cut it, and then done a try catch and pasted it back in. So now in here, we do have the option of creating multiple catches. So we could say catch, and then look at our exception list and see which exceptions we might have. And I believe there's one index out of range exception, which might be the case. Because if you access, let's say, data at position 1, and there is no position 1, there's no comma in here, so it's just one cell, well, then this would throw an exception. So you can say exception EX there. And then what we can do is have a separate handling of that exception, which we're going to do. So we're going to say throw new exception, and the exception is going to be, we have a message for it, and the message is going to be that invalid data in the coin text file. And then from there, we'll actually also pass in the inner exception, which is the original exception. And that way, we can create a nice, pretty message we can show the user, invalid data in the coin text file. That's pretty self-explanatory. If we show them the original message is going to say index out of bounds, and then it's going to have information about it. Well, that doesn't tell them much of anything. It's at least not for a user. For a developer, it should tell you exactly what you need to know. But for a user, it doesn't. And if we're going to display an exception to the user, we want the message to be nice and clean. And that's where we're going to clean it up with this particular message. And we'll also change the exception type to just exception. Now we could make it the index out of range exception again, so you can catch that separately in the front end. I don't think we're going to go that far, but this way we're cleaning up that message. in the coin text file has been corrupted. And it's a little bit a subtle difference between invalid data, which actually might say missing data in the coin text file. But the data in the coin text file has been corrupted is different because we're saying, yes, you have a value for data at position 1, but it's not a decimal. Therefore, it's an invalid number. Therefore, that's the issue, is it's a corrupted data. All right, so there's our exception. And in here, what we can do is we can just keep the throw. We can even take this off. And so what that will do is, in this case, it will just say, okay, we're going to catch these 2 exceptions, but if you don't have one of these, then just throw up the chain saying that there was still an exception. So pass it along. All right. So that allows us to cover any possibility, and it also gives us the opportunity to log these exceptions in here if we want to go that far. We're not going to right now, but this does make a much more robust design for our lookup because it covers these possibilities. Now, once we have this done, if it succeeds, then we're going to exit the try and we'll have populated output with all the different lines. Therefore, we can come down here and say return output. And you may wonder, well, yes, but you are doing this after your catches, so therefore, wouldn't it be that you could return bad data? And the answer is no, because our catches all do a throw, which means they're going to exit the method early. We'll only get here if this whole thing succeeds. All right, so now we should have, from this retrieve coins, we should have a working method of the coins. So we're going to retrieve coins. So let's do this. Let's say coins.add range. And this takes in an IEnumerable or a list of coin model. So therefore, we're going to say retrieve coins, like so. And what this will do is it's going to take our coins and it's going to add to it the existing coins. Now we have all the coins we need. And now we can start writing to our text file, which our text file is located. Didn't need to expand that. Our text file is located at coin text file. So we first need to create a comma separated list of all of our coins. So now let's use some link to create the lines we need to write. So if we were to do file.write all lines, we need a path. Well, that would be our coin text file. But then we need this content, which is a string array, or it's an IEnumerable of string contents. We can actually do this in line with link. So coins dot select, which control dot to add using system.link. And then in here we can say, let's do a C, the arrow function, and then let's do string interpolation. And in with the right all lines, and we're done. These 2 lines are all we need to save our coins. Now we can start wiring up these coin methods. So add coin, all right, or add coins. Well, we do save coins and pass in the coins we just received. That's all we need to do. Coin inventory get all. Well, return retrieve coins. We're done. That gives us just the coins we need. We can collapse those 2 since they're done. Now this next one takes a little bit more work. And we're going to withdraw coins. And so what we'll do is we'll first get the list of coins. So var coins equals retrieve coins. There's our list of coins. Now the really cool thing is, in our data access down here, we have that same retrieve coins, withdraw coins, and we wrote this, this where statement here that gets us our list and then does the remove. So let's grab this whole thing right here. We call it coin inventory, but we say coins. And then I think we should be fine. So we'll look. So we're going to say coins dot where amount equals coin value. Take that quantity and return it to list. This will be our list of coins. And this is how many we actually pulled out. So this is saying, hey, you know what? Give me this many and return that to a list. So we're going to say this is var coins to return equals. And that's going to return the coins. And then we're going to say coins to return for each of those coins dot remove that entry. All right. So it's going to remove from our list of coins we got from the database. It's going to remove the ones that we already are going to return. So that way we don't. If we remove them from the list, then we can save this coins back to the database or back to the text file, and we won't accidentally not remove them from the text file, essentially. But with this, it does raise an interesting question. Our save coins, we retrieve the coins from the database. But that's not going to work for this because we're going to want to save these coins, this coin list, back to the text file, minus the ones that we've removed that we've sent to the user. So therefore, we have to change our logic up here for save coins. So add coins, we can't just save coins. We're going to need to have the add range. I'll cut this out. We've saved the new list without the ones we withdrew, and we've returned the correct value. So therefore, that is done. Now we've done all the coin work we need to. Now we need to work on cash on hand. So let's create a private method in here that's going to be private. And this is going to be not a list of coin model like we have here or a list of machine info model. We actually need to return 3 different pieces of information. So this will probably be a tuple, which I believe down here for our cash on hand, we have a tuple. Yep, right here. we have as tuple. So therefore, let's just copy this tuple and come back over here, and we're going to say we return that, and this is going to be retrieve machine info. Okay, so we're going to load this information. So we're going to start with var lines equals file.readAllLines, and this is the machine info text file. And then we're going to do a try catch, and then we'll leave exception alone for now. Actually, we'll just trim this off and trim that up. We'll probably have similar catches in here. And we're going to say that instead of doing a for each, because all we're storing in here is 3 pieces of information. We're not storing comma separated. We're just storing 3 lines of information, 1 for each of our data points. So therefore, we can create a, let's create an out. So come down here, and it's read lines. There we go. So now, so this is an IEnumerable. Interesting. Well, we can just do a toList here. So the problem with IEnumerable is it does not provide the way for you to do this array level numbering of rows. So you can't say lines 0 and get the entry at position 0. toList, which is the one of the concrete types. IEnumerable is an interface. List is a concrete type that implements IEnumerable, and it adds some additional features. And one of those is the ability to count by number each row. So you can identify a row by its index number. So therefore we have soda price, and we're going to have output dot cash on hand equals, and that is also type decimal. So we can just copy this right here and put position 1, that's cash on hand, and then output dot total income, and that is at position 2. If all these work, then we're going to return output. Now, if they don't work, what are we going to do? Well, let's go back up here to our retrieve coin model. We have these exceptions. I'm going to copy the same exceptions, and I'm going to paste them down here because we have these same possibilities. 1, we could not have a position 1 or a line 1 or a line 2, or we might have something at line 1, but maybe it's not a decimal. So both of these exceptions would occur or could occur. So missing data in the machine info text file and the data in the machine info text file has been corrupted. So similar messaging, and that way it's consistent between calls, but at the same time it's specific to, in this case, machine info. Now let's go to another one. So we have private void save machine info. Let's make sure it was saved that I called it. Yep, save coins. So save machine info, and we're going to pass in these 3 values. We're going to assume you have all 3 of those. If you don't, you have to do a lookup first. So with those three values, then what we can say is we need to write all three of these. Okay, so we're going to create a string array, and this is going to be actually, it doesn't really matter, string array or a list would be fine as well. But we're going to create a string array, and this is going to be called save info or info to save, because save info might imply that we're saving it instead of this is the information to save. So info save equals new string array, and then we're going to create one that says soda price, and then we'll have cash on hand, and then total income, like so. Now it's going to yell at us because these are decimals, not strings. And it says can't imply or implicitly convert. So can implicitly convert from decimal to string, no problem, to string. That solves one problem. That solves a second problem, and we'll scroll off the page a little bit, but we'll solve a third problem. Now we have those three solved. We can go to the next line, and we can actually write this to the file. So write all lines, and the path is going to be machine info text file, and the contents are info to save. And then we'll write these three entries on three separate lines. So there's the save machine info. Now we can start wiring up our machine info. So machine info is going to ask for cash on hand. So var info equals retrieve machine info, and then return info dot cash on hand. Okay? Empty cache. Wipe out the cache on hand. So we'll first say var info equals retrieve machine info. And then we're going to say info dot cache on hand equals 0. And then we're going to say save machine info with passing in the three pieces of data. So actually we don't even need to wipe out the cache on hand. We can say info.soda price 0 and info.total income. That would do it as well. So you don't need to do this line. There's no reason for it. So now we're saving the machine info. But this is expecting back a value. Let's go back to our test and see if we're even capturing that information. So let's look at empty money from machine. And are you even capturing the actual? Yes, actual should be 0. So it's checking to make sure that the actual returned is 0, and also that what we've stored in the database is 0. So yes, what we need to do is we need to return just 0. Honestly, just verifying that yes, we've done this. on hand, I just return a 0. And I haven't reloaded this tuple. Therefore, this is still a correct value for what it was. So there's cash on hand. And now machine info soda price. This is one thing to point out real quick. I'm doing just a little bit of logic in here. You could create unit tests for this. If you do, what you need to do first is you need to extract out the system.io.files. So file.readAllLines and file.writeAllLines. I'm sorry, file read lines and file write all lines. I'm not sure why those two are different. But the reason we have to separate that out is because if you run unit testing, your unit test would trigger an actual read and an actual write to an actual file. That's not a unit test, that's an integration test. Therefore, we separate it out so you can mock that and make sure that it is doing what it's supposed to do. That'd probably be ideal, is to create unit testing for this and then mocking for the actual system.io.file. Another option would be to do integration testing on this. That seems a little heavy-handed. So I would encourage you create unit tests for this by separating out the actual writing. So we do, let's see, under retrieve coins right here. This needs to be in a separate method or a separate class so we can mock it. Okay, and we'll get there. Probably we'll do this in a later refactoring where we add more unit testing, because you can always have more unit testing. But that would help with identifying and making sure this is doing what it's supposed to do. All right, so with those two being done, now we need to get the soda price. Well, a soda price is just like cash on hand, really. So let's just copy this and paste it down here. But instead of cash on hand, it's going to be soda price. And then total income, just like the other two, is just that instead of cash on hand, it is total income. So those are done as well. Now we need soda inventory. Let's start with our method to create all the sodas, which is called what? Retrieve sodas, probably. So public list of soda model, and we're going to call this retrieve sodas. Let's retrieve all the sodas. We're not going to limit it to a certain type of soda. So the first thing you do is say var lines equals file.read all lines. There we go. So just say read all lines. I thought for certain up here somewhere was read lines. Huh. Anywho, maybe I just didn't read it quite correctly. So with this, now we can, wait a minute. Let me go back here and do Control J, and we do have a read lines. Now what's the difference between read all lines and read lines? Well, read lines says open the text file, reads all lines of the file, then closes the file. Okay? Read lines reads the lines of file. That does not say that it closes the text file again. And it does return an IEnumerable instead. I'm not real thrilled by that. So let's come back up here. Instead of read lines, I'm going to say read all lines, be consistent. We also don't need the to list, probably, because it's a string array, right? Yep, it's a string array. There we go. So pay attention to those things. Little details matter. So read lines, let's not use that. Let's read all lines because it does close a text file and release our memory. Okay, back here. Read all lines, and we're going to grab the soda text file. So this now has all of the lines from our soda file. Now what's a soda model contain? Name and slot occupied. And they're both string. Excellent. This is awesome. Because it makes our job a lot easier inside of our for each loop. So let's clean this up. There we go. And now we can say for each var line in lines. And then we're going to do a split like before. So var data equals line.split, and this is on the comma character. If your text has commas in it, you can split on a different character instead and make your life a little easier. Just do it consistently. You can't save it as commas and try and split on something else. But you could use like pipe is a simple one. So that's a pipe, and that's almost never used in text. But if you don't have commas, a comma separated value is most easily done with a comma. Now, it seemed like a comma separated value could only be commas, but I've not seen that to be true. It seemed like that name is a little bit of a misnomer. But in any event, we can split on commas because we're not saving commas to the file. So output, which we don't have yet. So let's create an output. So there's our output. So now output.add new. We're going to do this right in line because it's just simple. And we will say, what's the first item? Name equals, I did Control J there, by the way, to pull up that IntelliSense. Name equals data at position 0. And then Control J again, slot occupied equals data at position 1. And in theory, that does all of our work. And so down here we can return output. And there's our retrieve sodas. Now let's go back to the top here and go retrieve coins and grab these two exceptions. There's two catches for exceptions. And we'll paste them in. So index out of range, can we do that? Yes, we can, because we are accessing the different indexes. Can we do format exception? No, because it's string. So we don't know if the data is valid or not. We just know that there's string there. Therefore, we're going to call it valid data. We can't otherwise validate it. So missing data in the soda text file. All right. And then that's it for this method. We've now retrieved sodas. Now we need to save sodas. Public void save sodas. We're going to take in, whoops, I thought I had that on my clipboard. It's probably down the list. Let's copy and paste. List of sodas like so. And then inside here, we can say file.write all lines and pass in our soda text file and our sodas like so. And that should be, it's saying cannot convert from a list to an IEnumerable of string. Ah, of course. Sodas.select. We're just going to say S to be consistent. S is for soda. And then we'll say our string interpolation like so. And the first one is going to be s.name. And then comma, no spaces here. And then we can put spaces inside the curly braces because they don't matter. And they make for easier reading. But outside the curly braces, we can't put spaces because otherwise we have problems. So S. Our list of new sodas, and then we can say save sodas and pass in sodas. Done. Now check if soda is in stock. Let's look at our unit test and say soda out of stock. Let's look at what out of stock says. So it's going to look for these values. So we're looking for a Fanta in slot 4, and it's going to find it or not. Okay, so let's go to our mock data access and look for this same method. We say yes, otherwise return false. Okay. Now the interesting thing is our where clause here only checks for the name. It does not check for the slot. So if we ask for a Coke in slot 2, but we have a Coke in slot 1, this would say, yes, it's in inventory. But I don't like that. We need to actually be realistic here. So x dot slot occupied equals soda dot slot occupied. So therefore, we're going to check for both. We're going to check for slot occupied and the name and see if it is in stock. Our unit test kind of cut a corner, and that's okay, it can be. But for our actual logic, we need to make sure we don't cut the corners. So there's our check if in stock. Now we have our get all. Well, return retrieve sodas. So soda inventory get soda, where we check to make sure that we can get the soda and it's the right amount. Again, we need some logic here. So let's go back to our mock data access and look at the get soda here. All right, so these are the tasks we need to do. And this looks like cheating, but it's not. Because if you already have your mock, you already have your logic done once, then you can do this. And just change it to fit your new circumstances. So our var sodas equals retrieve sodas. And we can say sodas where soda name equals name. We don't forget, and x dot slot occupied equals soda dot slot occupied. Okay, and then get the first default. So it's going to get that soda, and then if the output soda is not null, we need to get the machine info. Retrieve machine info. All right, that's going to be our info. Whoops. There we go. And then we're going to say cash on hand, add this amount. Total income, add this amount. And then we need to save this, which is not how we do it. We say save machine info. We pass in info dot soda price, info dot cash on hand, and info dot total income. And we return that soda. So there's our logic done for us, where now we can return a soda from the inventory. Get types. I don't remember if this returns the whole list or not, so let's look at the get types. There we go. So what it does is it does a group by and selects the first from each of the groups. So we're going to say var sodas equals retrieve sodas. And then we're going to say sodas dot, I had 2 dots there, group by. And then we're going to have, let's back this off a little bit here. There we go. And then we're going to have this returns a list, which is what we want. So return, like so. There we go. So now we're returning our our same logic we did in the mock data access, because that's exactly what we are doing in our actual data access. Okay, so now we have our user credit. So we need to save this credit to our database, which in this case is just a text file. So this is going to be public, and it's going to be a list of what? We don't have a model for this. We could do a dictionary is probably best, of type string. Wow, if I can spell. There we go. And actually, not string decimal. And so we're going to say retrieve, and this is going to be our user credit. What it's going to do first is it's going to say var lines equals file.read all lines. There we go. And this is going to be the user credit text file. And then from here, we're going to do our try catch. And let's clean this up. Whoops. There we go. Shift delete, not control delete. Shift delete deletes a whole row, but it does a control X, essentially, a cut, and then you can paste it somewhere else, which I don't want to paste an empty row. And it does mess your clipboard up, but it does make it easy to delete lines. All right, so we have our try, and in here we're going to do for each line in lines. And then we're going to do a split. Var data equals line dot split. This should be pretty familiar by now. We've done it 3 times. Okay, so now we're going to say we need output, which output is going to be of type dictionary string decimal. Like so. And now we can say output.add, and we need to have a key, which is our first value. So data at position 0. And then we need to have a value. And our value is going to be decimal.parse data at position 1. And that's going to be our money for the user, how much credit they have. So with that, that's all we need to do to return output. Now let's go back to the top and grab those 2 exception types that we're catching. We'll see if we need both of them. I believe we do. So we'll paste this in here. And index out of range. Well, we're accessing things by index, and we have an index 1. So therefore, yes, we have an index out of range possibility. If you're only ever accessing position 0, we would not have an index out of range exception, because if there was a string to potentially split, then even if it was an empty string, it's going to return empty string at position 0. So therefore, if we're just accessing position 0, we don't have to catch for an index out of range exception, I do not believe. But if we have a 1, we definitely do. Now, if I said, I don't believe we do, and took this off, it wouldn't be the end of the world, because we still have this catch, which still does throw the exception up the chain. So therefore, we're not going to be, we're not going to avoid save user credit. And this is going to take in this dictionary. And this would be credits. All right. So what we're going to do is we're going to loop through each of these. So how are we going to do that? Well, let's do a file.write all lines. And we're going to do our lambda, file write all lines. We're going to say this is the user credit text file. There we go. We're going to say credits.select, and then we can do our lambda expression. So C arrow function, and then we're going to have our string interpolation like so. And inside here we will say C dot key, comma, and then C dot value like so. Now this is a decimal value, but it's going to convert it to a string when it puts it in here. So it's okay. You don't have to do a toString here. So now we have our key and we have our value with comma separated, and that's going to be how we store our values in the text file. That's all we need to do there. Now we can look at user credit underscore clear for this user ID. Well, first we're going to say var credits equals retrieve user credit. And then we're going to say credits for, we can say for the user ID. Whoops. Actually, there's a problem here. And I think the problem is I said we're retrieving a list of dictionary. That's not right. We should be retrieving a dictionary, which I'm not. It's not there, it's still 0, so we're good to go. So what we're going to do here is we're going to do a check first. So we're going to say if dictionary, if credits contains key user ID, then what we're going to do is we're going to set that value to 0. Actually, we don't have to do that. We have to do this if we're reading this, but we're not reading it, we're writing it. Because if we write this, and if there is no user ID in this list, it's going to set a new value for that user ID and set it to 0. So that'd be good, that'd be fine. If there is a user there, it's going to overwrite the value for it. So we're fine. So I was thinking if we're reading this, but we're not reading it, we're writing to it. Therefore, we can do our save user credit and pass in credits, and that will save our credits back to the text file, whether we've added a new one or whether we've wiped out an existing credit and set it to 0. All right, now with user credit deposit, this is where we'll need to do some error checking first. So what we're going to do is first do what we've done here. So let's open this back up, actually. We're going to retrieve the credits. So let's start with that. And then we're going to do an if statement. Actually, let's do a decimal, and this is new value. Wait a minute here. Before I go this far, we're not passing in a decimal here. So deposit, I was thinking deposit is going to be adding to we're going to add credit. That's down here. deposit is just where we take the value and we put it into the total money we've made. We basically wipe this out. Let's verify that by going to our mock data access and go to deposit. And what it's doing is if it contains the key, we throw an exception. If it does not contain a key, we throw an exception. Otherwise, we do this work and we remove the user ID from the credit. So let's go back over here and let's paste this logic in. So if credits contains the key, does not contain the key, throw the exception. Otherwise, what we're going to do is get the machine info. So this would be retrieve machine info. And then we're going to say that the credits, add the credits in the user ID to both the total income and cash on hand. And then we're going to have to save that information. So we're going to say save machine info for the soda price, which would be info.sodaprice, info.cash on hand, and then info.total income. Let's save those three values. Then we need to remove the user ID from our list, and then we need to save the user credit, like so. So now we have retrieved the information, we verify the key is there, because it can't deposit the money if it's not there. Then we have added the value of the credit to both the cash on hand and the total income. And then, which that is a decimal, so that's fine. You want to do conversion there. And then we've saved the machine info to save these two changes. We've removed the user from our list of credits. So the user is totally wiped out. And then we've saved that change to our list of credits. Okay, so let's go to insert. And since we've already been referring to it, let's make sure that we're going to get the value, and then we're going to add to the value. All right, so actually you can just copy this logic, come back over here, and we first need to get the var credits equals retrieve user credit, like so. And then we're going to say credits, try and get the value. We're going to add to it, and then we're going to save this. So save user credits, like so. Now, if we do a retrieval and there is no value for the current credit, then that is a 0. So 0 plus whatever you pass in, that's your new credit. So if this doesn't have to have a try catch, it was just going to work all the time. In theory. I'm sure it's probably something I've forgotten about. I think that's pretty bulletproof. All right, total. Let's just come down here and let's catch this, and we're going to paste it in here. We'll grab that initial line of the credits, like so. So this is going to look up the user's credit based upon their ID and return the value. And it's going to do a try get value. So there's no try catch needed here. And instead, if the user is not found, what's going to happen is it's going to return, again, a 0 for you don't have any credit. And that is all of the text file wire up we need. So let's refer to the challenge sheet to make sure we've covered all of our bases here. So the primary challenge was to implement the data access interface with a class that stores information in a text file. That's what we did. We've got the text file data access interface or implementation that implements the iData access. And we also need to make sure we don't change the interface we've already established, which we didn't. Cool. So we got the primary challenge done. Now I kind of mixed in here the bonus challenge. The bonus challenge is to ensure we have handled exceptions that might be thrown by the process. Well, that's what we were doing here. So you're catching these exceptions, these various exceptions, and also cleaning up that data. And we also wanted to get the information about the text files, this information right here. We wanted to get through an I configuration, which was passed in through the constructor, which we did. So you've accomplished the bonus challenge as well. So this is now complete. We have our data access layer up and running quickly, and it ensures that you can do this on your PC without having to install anything extra. Okay, so it's a good one to start with. All right, so that is our primary challenge and our bonus challenge. Hopefully you follow along. Maybe you'll learn something new. Try out the things that I've done, test them out, make sure that you understand what I was doing. And that's it. All right, so thanks for watching. And as always, I am Tim Corey.